Okay. Hi, everyone. Welcome to our last session of the Velociraptor deep dive course. And in this last session, we're going to look at how to extend Velociraptor, how to extend VQL. So we've seen how we can write a lot of VQL queries for various things as we go along. But we haven't, you've seen that VQL is a kind of useful language, but it's not, it's not a full-blown language, right? We're not going to write an operating system in it or something like that. So what I wanted to do is keep VQL very simple, but then we need to have a mechanism to extend it. So when it becomes more, when we need to do something that's a bit more complicated, then we need to have a mechanism to do that. So that's what we're going to be discussing today, is how to extend VQL in an API and other things like that. So that's today's module. So let's think about VQL. So ultimately, I wanted to create a very simple language, right? So it's easy to use, right? But there is a limitation there, right? And some things are still too complicated to do in VQL, and sometimes we might want to do things that are that access parts of the OS or parts of the platform that we're running on that we don't have hooks for in VQL. So for instance, if you want to know about interact with certain APIs and and load external DLLs and that kind of thing, then we might not have those features in there. So so we want to explore how to extend VQL. So let's think about, what does it mean when I say extending VQL? Well, what I'm actually meaning by that is we want to write additional artifacts that we want to write some VQL in such a way that it kind of hides something that's very complicated or more complicated, and we can use it in VQL in a simple way. So the obvious thing, the first thing that comes to mind with extending VQL is just VQL artifacts, and we've seen that before. With VQL artifacts, we can essentially write a whole complicated VQL query, put it inside an artifact, and then just call it from another VQL query. So let me just start the Velociraptor GUI, which is what we do every day, Velociraptor GUI, and I'll show you what I mean by that. So if we start a notebook, go to one of our notebooks, or maybe we'll just create a new one, module 7. Okay, so create a VQL cell, and if we call something like select star from, and remember we discussed this before, if we use the artifact keyword, then we can call another artifact. So for instance, in this case, windows.sys.users. If I just call this, then it calls that artifact inside Windows sys users. So essentially, it's encapsulating all of this very complicated. There's actually quite a complicated query inside of this artifact, but it's hidden away. All we're doing is we're calling it. So that's kind of what I mean by extending VQL, because you are able to present. So this looks like a plugin. So it's just like we created a new plugin, and people can call that plugin and get new functionality without having to worry about how this actually works, right? So essentially, it ends up calling a whole bunch of other VQL inside of that. So that's the first example, but it's kind of cheating, right? It's not really what we mean by extending VQL, because at the end of the day, you still end up with calling another VQL query internally, right? So I mean, from this query here, I don't know what's going on inside of these Windows sys users, but I can easily have a look, right? Open another tab here and look for the Windows sys users, this one. And you can see that there's a whole bunch of VQL here that's going to run, right? But it doesn't extend VQL as such, right? Because I mean, it's just, I could have just copied this entire thing and put it here, right? And it would still work. So I'm not extending the capabilities of VQL in this example, but I'm hiding a whole complexity inside something that looks like a plugin. So that's the first, but that's the first level of encapsulation and reuse of code. But it doesn't really help because we're still limited. We still have the capability, limited by the capabilities of VQL. So for instance, if I wanted to do something like access, Windows APIs for doing something, then I still can't do that because, there isn't really a VQL that will do that unless VQL has that capability. So we need to have something that's a little bit outside, the VQL capabilities. And on Windows, the obvious tool to turn to is PowerShell. And similarly on Linux and other things, we can use Bash or Python or whatever is on the platform. But in Windows, most of the time we end up using PowerShell because it's always there and it's always installed on the endpoints. To some extent, there's different versions, and sometimes you only get the old version that's installed. But PowerShell is actually pretty cool. It's a great language, and it's a very powerful language, and you can do quite a lot using PowerShell. But what's more important with PowerShell is that PowerShell actually has hooks into a lot of the applications and the lower-level APIs that we don't have, right? So for instance, if you have something like pretty much any enterprise software today would have PowerShell integration. So if you, for example, like Azure or Office 365 or whatever, they have PowerShell commandlets that allow you to query the state of that application in a very precise way. And for us to actually in Velociraptor to replicate that work doesn't make any sense. Doesn't make any sense for us to write specific code for these things. So it actually makes more sense for us to just rely on the PowerShell integration to query these data sources as much as possible. So what we really want to do is we want to wrap the PowerShell scripts in a VQL artifact. So this is kind of the purpose here. So let's have a look at an example, and we'll work through an example of how we do that, because it's actually pretty straightforward process. So let's look at this PowerShell snippet here, and it's only an example because again, we already have VQL plugin to get the list of processes, which is select star from PS list, right? So it's we already have the capability. So, but there's no point doing that. But I just wanted to do that as an example because it's a very simple example. So let's start up a new PowerShell, right? And we're going to run this PowerShell snippet, I guess. And PowerShell has this thing called commandlets, and then you use pipe, and it's got a command called select, which just pulls out columns, individual columns from these things. So anyway, this basically looks like this, right? It just has it draws it up as a table. You've got the name of the process, you've got the ID, the PID, the process ID, and then you have the path of the process. So it's just a very simple PowerShell. And what we might want to do is we want to write VQL to do that, to basically rely on PowerShell to get that information, right? So let's see how we might do something like that. So let's first of all put our command script, right? We call it a script. Script equals. Okay, so we're going to put that here. That will be our variable. And what we want to do really is we want to shell out to PowerShell to run this command, right? So in VQL, we can shell out to external programs using the execve plugin. So the execve plugin is sort of like on Linux, it just makes a system call, and it just takes argv, right? So it's a list of parameters, list of arguments. So it's exactly the same how you would use it in Linux, except that you don't really just run a command line. You have to separate that into a list. So we can then sort of do this PowerShell. Now, PowerShell is great, but it has this very annoying execution mode where you have to essentially, essentially always put this parameter in front, which so it's not even a security thing. It's just a annoying thing. Execution policy unrestricted. I don't know why you have to do that, but it's not really a security thing because it's very easy to bypass. You just put this command line option in there, but it's required. Otherwise, nothing works. So unrestricted. So it's just there to annoy you. So when we do that, then let's just say for PowerShell, you always have to put that in there, so it runs the thing that we wanted, and then the -c command says run this command, right? So we're going to run this command. So -c, and then the script. Now, one thing to note here is that we always use an array of arguments. So we don't just write one command line, right? And the reason that we do that is because, yeah, sorry, thank you for spotting this unrestricted, yeah. And the reason that we do that is for security, right? Because you might have heard of command line injection. And in command line injection, people tend to do something like interpolate a string into the command line, right? So you might be tempted to do something like running in like PowerShell -execution policy unrestricted -c and then plus script, so something like that, right? But that would be very dangerous, right? Because of this command line injection vulnerability, right? So what we try and do is we just don't provide this capability. So you can't really run a command line like a naked command line, I guess. You have to use this this argv as a list, and then it will get escaped, right? So this entire command will get escaped correctly. So let's see how that works. So we click save, and then we'll run that query, and that's pretty cool, right? So it basically runs the query and dumps out the output. So execve as a plugin simply shells out to whatever it is that we're running, and then it gives us an std out, std error, return code. And then the very last row says it's complete, so true for complete. Now you can see that what it's actually doing is it's splitting it up into rows, right? So if the sub-process returns some data, then for each row will separate it into a separate row. So that's okay if you have something that that takes a while to that sort of like feeds in data a little bit at a time. So you get each row as it's produced. So that's cool. But you see, that's very hard to read, right? Like if I actually try to do that, it's very difficult to read. What I actually really want from this is I want to be able to actually just get the proper table out of it, right? I want to get a proper Velociraptor looking query that just looks like these columns. So in the end, I want to have a column called name, column called ID, and a column called path, and then have everything in a sort of structured way. So that's ideally what I wanted to do. Okay, so I just in here I've got a couple of slides here before I go on to the next thing to just explain how we can run scripts. So what the first way is with PowerShell with the -c flag, it just runs this command. Now it will do the correct escaping and basically build up the command line, sort of correctly. But as you know, a lot of the time it's actually quite difficult to get the escaping right. So Velociraptor should do a reasonable job of doing the escaping, but for a lot of cases, you might want to encode the command. So when you encode the command, it basically runs. Also, if you just take a look at the logs down here, then it tells you what this is the log. It's telling you what we ran. So this is just a way the execve plugin just logs what it actually ran. So in this case, it actually kind of interpolates that command line into the path, that script into the path. But if you want to have, if you don't want to have, if you want to encode it in a way so that it doesn't interfere with all the shell characters or whatever, then you can use this encoded command, and then you encode the script as a base64 string, right? So that's encoded command, and then we just use base64 encode. What parameter does it take? A string. Great. So we have to base64 encode it, and then UTF-16 encode it. So this is just a Windows thing. So you take the string and then you UTF-16 encode it, and then base64 encode that. So F16 encode string equals script. Let me just bring that along here. Okay, so we encode the script, the script path with base64, UTF-16, and then we encode with base64. So that should work the same way, right? And except that we will see the command that ran is sort of like this, right? That's the command that ran. So we're encoding it and running it sort of at the same time. And that technique is a little bit more reliable when you have like bigger scripts with maybe more quoted characters and so on. Finally, when you have a very large script that I mean, this is only one line, right? But when you have a very large script, there is actually a limit on the size of the command line. And in the previous method, we ended up essentially encoding the script into the command line, and then we have a very large command line, right? So there is a limit on that size, and so you might hit that when you have a very large script. So in this case, what you actually can do is is just store it to a temp file, and then call the temp file, right? So you can just use that technique for very large scripts. Okay, so let's go back to our output. So here we have this this output here. I'll just close this, and it's kind of hard to read. It's very hard to read and understand what it's saying. So what I want to do is I want to convert this into machine readable format, so I can actually process it. So what I could do is I could go over here and tell PowerShell to encode it to something that's machine readable. So the easiest thing is to convert it to JSON. And this is part of, so this is I'm changing the PowerShell script to convert the data and create valid JSON. So when I do this, it's now going to output the result as a JSON string, right? So, and then the idea is that I can use Velociraptor to parse it from JSON from a machine parsable format into something that I can use in VQL. So there's a couple of problems. The first problem is that, as you can see, the JSON is split across multiple lines. And so if I try to parse it, it's not going to work because you see it's not valid JSON. Each line itself is not valid. So what I need to do is I need to actually take all of that JSON and put it together into one big string so I can parse it at once. And how we do this is we just tell the execve plugin to use very large buffers. So by default, it has a certain size of buffer, and I think it's like maybe 1K or so, which is not huge. And then as soon as that buffer is full, then it sends a row, right? But what we really want to do is we want to say, look, wait until the end, and then send one row with all the data in it. So this essentially specifies the maximum size that will be buffered in memory. So like, let's say 1 megabyte is probably more than enough, right? And so when we do this now, then it will wait up to 1 megabyte and then send it all at once. And so now we have a valid JSON string, right? It's a JSON array and it's valid, which is in std out, but it's still sending rows, right? So what we might want to do is for each of it, there's only one row, right? But but it's still a row. It's still sending multiple rows. So we can just we can simply use the for each plugin and say, okay, for each of those rows, right? What would I want to do? Well, I want to parse it. See, it's a JSON array, right? So it's an array because it starts with a square bracket and then it has, dictionaries, right? So I want to parse that std out, right? And from parse, so it's a JSON array. So it's not just the JSON object, it's a JSON array. And okay, data equals std out, right? So it's this column, so this cell will go into this plugin, which just parses it out as a JSON array. So it's an array of JSON objects, and then each of those will be, emitted. So let's have a look as a row, right? So it's gonna basically run the thing, encode it, and then in VQL we decode it and we just release it as an array, right? So now you see, now what we end up having is something that looks very much like any VQL query, right? This is a VQL query that looks very much like like any other thing, right? It has columns, it has rows, it's all basically the same thing. So this is pretty neat, right? We can make it look like we just called another VQL thing. And that's really what we are looking for when we're saying extending VQL, is we're saying we'll use PowerShell to do the heavy lifting. Then we're going to take that and present a table so that it looks like just a normal VQL plugin. So this is just a query, right? But it's not yet a VQL plugin, if you like. So let's make that into an artifact. So I'm just going to copy this, and I'm going to go and create a new artifact here. And let's just say, it's going to be a Windows PowerShell PS list, for example. And then we just, okay, it's going to be, we can simply paste that script, tab it twice. All right, and then it's going to be just for Windows, so we can clean that up. let's just say, for now, this is fine. We don't really need a description. So what we've done now is we've written an artifact. So here's our artifact. And we just put that query in an artifact, right? So, and then we gave it a name, right? And so it's the same query. So what I'm doing now, if I go back to my, okay, let's go back to a notebook and create another VQL cell. And what we could do now, select star from, because it's an artifact, it was a custom artifact, Windows PowerShell, that's the name of it. So now this basically will call that VQL in it. So what remember in the first example, we talked about encapsulating VQL in an artifact. So it's hiding the fact that there is VQL going on. And that in itself wasn't useful, except that now that VQL is actually the interface with the PowerShell. So it's shelling out the PowerShell behind the scenes and running something in PowerShell, right? But the results that it's bringing back is just like any plugin. It looks like a plugin for the caller. And in fact, the caller doesn't really care that it's using PowerShell or any other thing, right? So it doesn't know or care about it. I mean, we can still see the log messages that it's calling execv to execute the PowerShell command, but it doesn't. But as far as we're concerned here, we don't really need to worry about that. So that's essentially what I mean by extending VQL with PowerShell. And that's actually a super powerful technique, right? Because you can essentially use any kind of VQL to get that information, right? So again, just going back to this example, so we're converting to JSON, and then we're parsing out the JSON array, right? So there's actually two flavors of parse JSON array. I use the plugin version here. So it's a plugin, but also you can use the function version, but then it's just going to make a big array, and then you could iterate over it as well. So there are just two different ways of doing the same thing. And then we parse it. And so we really need that length equals 1 meg, and that specifies our internal buffer size. And then and then it basically just works, and it looks like just another artifact. So it looks basically the same, and we can just call it. And then the cool thing is that we can actually also use, because this looks like a plugin, so I can just continue on, right, where name matches Velociraptor, and and essentially that will do this post filtering. So I can continue on to filter that with VQL and everything, because it just looks like any other VQL string, a VQL query, right? So that's encapsulating and extending it. So is there any questions about that? No? Cool, that's pretty straightforward. And once you've done it a couple of times, you just end up doing the same thing, because the actual VQL part of it is the same. You just change different scripts. We do have one question. Is it correct that the MSI should be installed the first time on the endpoints with administrator level? Yeah, I mean, the MSI should be installed with administrator. So the MSI that is created, it requires administrator level, because it's running as a service. So you can't actually install it otherwise, right? Because it needs to create a service. Yep. All right, cool. So yeah, so that's cool. Let's have a look at the next step. Now that we find out that we can run arbitrary PowerShell, and in fact, you don't have to run arbitrary PowerShell. You can run anything else as well. we can actually think about remediation. So here's an example, and this is actually something that we did in an actual case of I think it was a crypto miner infection in this case, and the customer had I think a large number of machines. It was more than 1,000, I think, that were infected with this crypto miner. So like 1,000 or 2,000 machines, I think, from memory, that were infected with the crypto miner. And if you've ever worked with crypto miners before, or in fact many types of malware, they have a lot of persistence mechanisms that will reinfect the machine. So you go and remove the original infection, and then the next day it comes back, right? Because there was some persistence mechanism somewhere that that reinfected the machine, and you didn't find it, and it just came back, right? So one of the common persistence mechanisms that they use is the scheduled task, because it's kind of like dormant. You can essentially set up a scheduled task that run at a particular time of the day, and then it just runs and reinfects the machine, right? So this is an example of such a thing, right? So we can create this task, just for testing. So here's how you can create a task. Oops. Copy, paste. Just copy and paste that one. And what it does is it uses the Sketch Tasks program to add or schedule a task. And we're creating a task, right? And it's going to be running daily, every day. This is the task name. We're going to call it evil task, but a lot of the time this name would be like a random string or something. And then this is going to be the command that's going to run, right? So we're just going to do something harmless now, like dir. But, in reality, this will be essentially calling, the binary for reinfecting, or it might be a PowerShell script or something, right? That will run at a particular time to reinfect the machine. And then this is the time that it will run. So, 8 p.m. it's going to run. So let me just see if we can see this. You can actually just see it with Task Manager. No, sorry, this is not Task Manager. You can see it with the schedule tasks, task scheduler, sorry, because we created a new scheduled task. And let me just look here. So you can see the evil task, right? So we've just added it here, and it's just being created, right? And so, a lot of the time it would be kind of hard to identify it. It wouldn't be called evil task. They might call it something that looks like some of the other tasks, or a random name or something like that, right? So try and hide this, but this is the persistence mechanism. So we can, remove the malware, and then at 8 o'clock the next day, it comes back, right? So, so let's have a look at how we might, we might detect these things. So with Velociraptor, I mean, it's very easy to detect, right? All we do is we create a hunt, and we're going to look for scheduled tasks, and look for it here. Scheduled task. So this is just listing all the scheduled tasks. It goes and parses it, and we run it. We click go, and it goes off and does it. And so we'll be able to see all the scheduled tasks from our entire fleet, and then we can even identify it, right? We can identify the malicious tasks, so we can do our post-processing as normal, and and then we might be able to identify that's our evil task, right? So that's cool. But now, what do we do about this, right? So we can go and delete it from each individual endpoint. But if we have 2,000 endpoints, how are we going to do that, right? It's just not scalable. So what we want to do is we want to actually implement remediation in Velociraptor. We want to go in ahead and remove that scheduled task. So this is what remediation is all about. It's about actively responding by removing or disabling the the vulnerability. So you can actually do this. There is an example here of a remediation type artifact, and let me just show you that really quickly. It's just an example. It's actually the same artifact that we ended up using in the same job, but but essentially what it does is we do the same thing as before, right? We just read the so this part was copied from the scheduled task artifact, so it's parsing all the scheduled tasks correctly. And then what we've got is some parameters that allow us to essentially zero in on the evil scheduled task. So remember, one of the things that we're trying to do when we do remediation, we don't want to kill the system, right? We don't want to cause damage. So what we want to do is we want to identify the malicious task, scheduled task, and remove that, but not cause other damage. So, so essentially, we're listing all the tasks here, and then we have some filters, right, based on argument regex and command regex, so we can identify the malicious tasks, and then we, if that filters succeed, so that it matches, right, then we log the message removing task, and then we go and actually remove it, right? And then we have two possibilities here. We have a really do it parameter, parameter. And if it's set to yes, then we actually go ahead and remove the scheduled task. Right? And then, so we have an if condition here. And if it's set to yes, then we go ahead and exec VE the script, the PowerShell script, to actually remove it, right? But if it's not, then we just display it, but we don't do anything, because it's like a dry run type thing. So that's also very important in remediation, because you can actually cause a lot of damage. And so it's very important to know or get a really good sense to what is going on, right? Like what is going to happen when we actually do this. So I'm just showing you this, but I have to also stress again that when you do remediation, it's quite risky. And so you really need to be very, very careful and very methodical about how you do it. So let me show you this. Let's work through this example and I'll show you what I mean. So in this case, we have the evil task. And, again, the name evil task is probably going to be random. So you can't really match on that very easily. So, so that's why we wrote our remediation artifact to go for command and arguments, dir and c, right? So that's what this scheduled task does. But let's suppose that we decided that this dir command was the malicious command. So what we might do is we might might try to remediate this. So remove evil tasks, right? And there is this remediation artifact. So we just simply remediation. Okay, there it is. This one, the one that we just looked at. And then we'll configure the parameters. And so this is the script command that will run to actually, to remove that scheduled task. All right, so it's just a PowerShell snippet that does that. Then we're going to parse all the tasks, and then we're going to see if they're matching these unique names. And in this case, the command was called dir, so we'll go dir, great. And then the argument, let's just say that we decided that dir was like really evil. And so that was a good signal for that malware, for that scheduled task. Because again, that scheduled task could be present on thousands of machines. So so let's just do a dot here. We'll just select all arguments. And then I have this really do it thing. And I'm going to leave that off, right? Because that's like a dry run. So when I launch this, okay, so off we go. Then I expect to only get exactly the evil tasks, right? Because I expect it to be very selective and show me exactly, what it would have done. And I can see immediately that something is very wrong, right? Because suddenly I have a whole bunch of tasks here that would have been removed if I hadn't done the dry run thing. And they are obviously correct, right? Like this is part of the system, right? So it means that if I didn't have a dry run and I just went ahead and did this, then I would have done some amount of damage to the network. Right? It's not good. So I've got to go back to my drawing board and think, what happened with my command? I thought dir was the evil command, right? But you can see that suddenly it might have been the evil command, but it's not a very good match, because you can see that it has, it matches elsewhere as well, right? So it's not a very good filter. My regular expression is not great. So let me just copy this hunt and try and fix up these parameters. So when I said dir, maybe I could say something like anchor it at the beginning and end of the line. So it's just dir, right? So it doesn't have any other thing. So let's try again without the really do it. So off we go again, and do the hunt. Now, we're still doing a dry run, but you see now we actually have a very, very narrow, selection, and because the filtering is much better now. The regular expression is better, and I don't have any false positives. So now that I've checked that, yes, I actually I like this, right? This is pretty good. So now I can simply copy that hunt again and then say, okay, let's really do it now, right? So let's really do it now, and then click launch. And now that I do it, I'm pretty confident that it's a pretty good, very tight, expression, and it's only going to affect those malicious tasks. And then it will also tell me which ones have, have been removed, right? So if I look at each individual flow as well, then I can look at the logs, and I can see that it's running the command. So this time it will actually run the remediation command, right? Because it is, I clicked the do it thing. So you can see that it's gone ahead, remove that thing, and remove the scheduled task. And well, I can just do it again next time, and then verify, right? So that's the process, right? So the lessons to take out of that are: be very careful, right? Test. So have a dry run feature in your artifact. Let's go back to how that's implemented. So make sure that you kind of understand how this artifact, how this VQL works, right? So this really do it is defined as a bool type, and this is why the UI shows us a little checkbox. And you can see there is an if condition. An if condition means that if this is true, then we run this query. Otherwise, we run this query. So you can see that this query is the one that is the business end, right? The one that actually runs the removal script. But this query, it simply shows us what would have been done, but it doesn't do any running. So it's just an empty query. Just select these from scope. Right? So it just shows us what would have been removed. So dry run, very important. But yeah, and then have the selection mechanism here. So I mean, this is, it might be a different kind of selection. So for instance, you can get really complicated here a lot of the time, the malware would be in a random place. It would be in a random location on disk. They just kind of copy the executable everywhere on the disk, and it might change the hash or whatever, right? And then and so you have like random names and random paths. So it makes it very hard to identify the exact malicious task. So you might actually even end up doing something like selecting the task, finding the executable on disk, finding and then looking at the hash of it, and then identifying it by the actual executable on disk, or something like that, right? So you can actually do some pretty complicated things here. Cool. So yeah, so that's remediation. That's kind of all I kind of wanted to say about that. It's possible. We don't really try and do it too much because it's kind of risky, but in this case, they had like 2,000 endpoints. There was just no way they could remediate it otherwise. And the other option would have been to write some hacky PowerShell script or something, and then try and push it out through group policy, and then you have no feedback about how it worked or didn't work, and then it's just as easy to make a mistake in your remediation PowerShell scripts and cause a lot of damage as well, right? And having Velociraptor do that is probably preferable. Okay, cool. So the next topic. Is there any questions about this for now? No? Cool. Cool. Okay, cool. So the next topic I wanted to cover is using external tools. And this is like the next logical step, right? So we've talked about extending VQL with using PowerShell, right? And PowerShell, when you think about it, is it's just an external programming language, right? That just happens to be sitting on the system, right? So the next logical thing is to say, well, what if we actually have an entire different tool, so like another binary, and then we just shelled out to that, right? Instead of having shell out to PowerShell, we'll shell out to whatever external tool it is. So that brings the concept of having another tool, and the diff.ir field has lots of tools, right? Because people love to write small, very targeted tools or programs to solve specific problems, right? So if someone reverse engineered a particular forensic artifact, and then they'll usually write some Python script to parse it, right? And then that Python script can parse that artifact, and that's it. That's all it can do, just parse that artifact. So then a lot of the time we will take that Python script, convert it into an executable using py2exe or PyInstaller or something like that, and then we end up with just a simple program, simple executable that can just do the one thing, and that's it, right? It just parses this whatever, right? Whatever different file type that this researcher has figured out, right? So of course, we would love to write a proper parser, but sometimes we don't have time. We have to take that and then use it as much as we want, as much as we can, before we can re-implement their work in in VQL. So we might as well just use the tool as it is. And sometimes the tools are very, very, very good, right? Very sophisticated. So we might want to use those as well. So that's the reason why we want to use an external tool rather than reinvent the wheel. Let's use someone else's tool as it is. So, but that presents a number of problems, because what we're doing is we're actually running this tool on the endpoint, right? We want to run this external tool on the endpoint. So how do we get it there? First of all, like how do I actually make that tool appear on the endpoint so I can run it? So and then once the tool is on the endpoint, like, do I have to push it out every time? And because now we're dealing with scale, right? So we have 10,000 endpoints. Do we want to, even if we push a tool that's like 2 or 3 megs, then it's quite a significant amount of bandwidth all, in aggregate. So if I wanted to use that tool today and then I wanted to use it again tomorrow and the next day, do I need to constantly pushing that binary out to the endpoints? I mean, it's the same binary. Wouldn't it be better if we could just cache it on the endpoint so we don't have to constantly do that? So these are all kind of considerations around using tools. So what we really want is a mechanism where Velociraptor can take care of that. So make it super automated and super easy to use. That's really kind of the goal. So if we use Velociraptor to manage the tools, then it will just make sure that the tool is delivered to the endpoint. So when we call it, when we want to use it, then it makes sure that it's there. And then we make sure that it's integrated in VQL, within VQL. And then the other thing is we need to make sure somehow that the tool is producing machine readable, data, because then we'll be able to parse that output somehow, and then get some structured output. Because really VQL is really all about structure tables with columns, right? So, so a lot of the tools, they are written for humans to read the output, right? Like Red Reaper, something like that. A lot of the Red Reaper output it's detailed, but it's very difficult to machine parse it because it's just free form, right? And so that's a very difficult tool to work with in a structured way. So ideally, also the tool author would produce at least a CSV or a JSON mode so that the output is structured. So let's have a look at an example. So to actually understand, let's look at it. Oh, there's one more slide here. So the thing about tools is, Velociraptor tools is that they are cached on the endpoint, so we don't need to re-download them each time. And also there's a separation of responsibility here. So when you think about it, when you write an artifact, you might say, I want to use WinPMem in my artifact. That's an external tool. This is where you get WinPMem, right? Normally, GitHub or whatever. But depending on your situation, as an admin, you have to be able to control where the tool is actually coming from, because maybe you don't want your 10,000 machines to go and download from GitHub, right? Or maybe you can't have that. So you might want to actually serve it from somewhere else. So there is a separation of responsibilities here where an admin can control how the tools are actually delivered to the endpoint, or they can even override it. They can say, oh, this WinPMem, that's an old version. We want to use a different version or whatever. So they can force a different kind of tool to be run there. Whereas the artifact writers, they don't really have a visibility of what's happening from an operational sense. So they just kind of specify, I'm going to write an artifact that just deals with WinPMem, right? Just deals with downloading memory images, and then they just say, this is WinPMem, this is what I need. I'm going to call it with these parameters, with these command line arguments, and get the results back. So we have to have a mechanism where this is a separate responsibility. So essentially that turns Velociraptor into an orchestration agent because it's doing all the orchestration for you in regards to tools. So we have a question. Would you recommend an offline collector configured to collect cape triage artifacts, run autoruns, and create memory dump with WinPMem? So yeah, so with the offline collector, and we talked about that yesterday, if you recall, I just showed you that when you choose an artifact that uses an external tool, then it will include that tool in the offline collector. So in the example that you were saying, you're going to run an offline collector, you're doing cape triage artifacts, you're going to run autoruns, you're going to run WinPMem. That's fine, right? Velociraptor will by itself package all those binaries, the autoruns binary, the WinPM binary, in the collector, and then it will deploy it when it collects it. So it essentially copies it to a temp file, then it cleans up after that, and then it launches those tools, and then the output of those, is going to be included in the collection, the collection zip file, right? So that's the idea, right? I mean, the idea is to make it very transparent, very, very simple, so you don't need to be so you don't need to worry about it. Okay, cool. So let's have a look at an example. So autoruns is the classic example here, but there are many other tools as well. So autoruns is a sysinternal tool. We did that one yesterday, but what we're going to talk about now is we're going to look at more details of how it's actually implemented. So it's obvious why we want to use autoruns, because it's cool, right? It's really good. It's a very, very powerful tool, and we don't want to reinvent the wheel. So what we're going to do is, so we can look at the autoruns for Windows. So that's great. And they have a download link, right? On the autorun, on the sysinternals pages. And also they have this sysinternals live thing as well, which is a very nice way of distributing the binary. So, you don't have to install it. It's just the plain executable. So that's nice. Okay, so let's have a look at an example. So we're going to add a persistence. This is a fairly common persistence mechanism. And what it does is it creates a service on our machine. See, and it uses services have to behave like a service, right? So the service control manager will start this service, and instead of giving it a proper binary to run, we're giving it essentially a command line. So compspec is an environment variable, and it expands to the cmd.exe, the command.exe. And so we're just giving it a command line, and then it runs PowerShell and it does some stuff. This is coming from the Atomic Red team. Remember, we talked about that yesterday when we talked about hunting, right? So this is their test. So, the idea is you install this thing and then you start the service, and then the service control manager tries to launch this, right? But it's not an actual service. So it will just go, I can't talk with you. And then it will just shut it down. But it's too late because it's already started running. And, and essentially it's an escalation to system level. So let's copy that and put it in our example here. So this is the example, right? And it's just created a service, right? So now we can start it, sc.exe, start, owned. I mean, this is kind of how it works. It's not going to work, but you see it still runs. And as part of running, it would have created that file, right? That's the sign that says it ran, right? I mean, again, this is a Atomic Red team test. So this is kind of the exploit, how it works, right? But what we want to do is we want to see whether this, this particular, so this is like a persistence mechanism. So, I mean, we can go ahead and check the services and all this sort of stuff, but in this case, we want to use autoruns to actually tell us this, because autoruns is really cool. And that's one of the places where it actually looks for it. So let's go and launch the autoruns service, the autoruns artifact on this machine. So I'm going to select that machine, searched it, and I'm going to search for autoruns. So I have a Windows sysinternals autoruns. That's the artifact that I want to launch against it. And you can see what it's doing. So this is the query here, that it's actually going to pick the tool. We're going to look at these in more details in a minute, but it's going to basically launch that tool with an execve, right? and it's going to give it the arguments. Right? The arguments are no banner except EULA. These are all different arguments. And so we're going to launch this thing. Now, the other thing that you would have noticed here before we launch it is there is this very interesting new buttons that you haven't seen before. And so if we click on those are that's the tool setup screen. So that screen here is allowing us to set up or control how the tools are are going to be pushed to the endpoint. How we're going to do that. So the first thing that we'll see is that there is a tool name. So each tool has a name, and then there is an upstream URL, which the upstream URL is what the artifact is telling us. So the artifact can basically point out to say, if you want to get this binary, that's where it is. Go get it from there. And then, we've got hashes and other things like that. Now down here, it's going to tell us that it actually is going to be served locally. So in other words, it's going to be served from the Velociraptor server itself. So there is a public directory, and then we will create essentially a secret path in the public directory that you can use that it will use to upload to fetch that file. And then we can change that. So if we click on this, serve from upstream, it will actually end up downloading it straight. So the endpoint will download it from sysinternals. But the sysinternals site is not super reliable, so I wouldn't recommend to do that. So also, you can just set the serving URL. Like if you're going to serve it from an S3 bucket, then that makes sense. You put the URL here. And that's basically it. So it's just designed to be super automated. So you don't really need to do anything special with this. You just launch it and off it goes. It's going to run auto runs on the endpoint. Now, I just wanted to quickly show you what is happening under the hood when we do this. So I'm going to show you the request that is actually sent. And this is the VQL. We haven't really looked at it in very much detail, but the way it works is that when we run an artifact, when we launch an artifact against the endpoint, the server will take that artifact and it compiles it into a request, which contains basically plain VQL. So when we collect an artifact from the endpoint doesn't really use, I mean, it's all the same binary, right? So it has the artifacts built in, but it doesn't use those artifacts. It doesn't use its own artifact to collect, right? Every time we send it new VQL, it runs the new VQL, right? It makes sense because if we upgraded the server and changed the version of the VQL or changed the artifact, then we want the endpoint to run the new version of the artifact, not the old version. So every time we compile the artifact into these VQL statements that we are sending at a low level. So when we are sending this an artifact that has tools, then you'll see that we are filling up an environment variable here with the name of the tool. So there's the hash of the autoruns tool, and there's the file name, and this is the URL where the endpoint is going to download it from if it needs to. So, and then for each tool, we have to provide this information, right? So that's what the server is doing. So the server is telling the endpoint, this is what the tool is doing, right? This is where you will get it. Then we run the query. And then when the endpoint actually wants to use the tool, then it calls this very special artifact. It's not special, it's just an artifact with this name, right? Generic utils fetch binary, and specifies the tool name. And all it is that artifact simply, again, the endpoint doesn't use its built-in artifact. We push an artifact definition to it for that. And this is where we actually tell it where this is the implementation of this artifact, right? So that's the request, right? So in the end, it's very transparent, right? We don't really need to do anything. The endpoint is basically, it's going to receive the query. It's going to check the local hash of its locally cached executable. And remember that we told it what the request basically tells it what the hash is supposed to do or supposed to be. And if it is the same hash, then it just uses it. So in this case, it just checked the hash of its local cache and just went ahead and used it, and then just shelled out to it, right? And passed the results as as rows. So it's the same thing as we've done with the PowerShell example. But if we didn't have that copy locally, then it would actually go and download that from wherever it's being told to download it to. So that's kind of how it works behind the scenes. And then as a result, we can see this is the output from autoruns. So that's cool. So we can now post-process the result, and we can say, where image path, and unfortunately, autoruns has a space in the name of the column, so we have to do a backtick. Image path, because that's the name of the column, has space in it, matches comspec. So if we do that, or PowerShell. PowerShell. No. Launch long string. I think is it this one? The launch. It depends on how autoruns calls. I think it's launch string, actually. So these are all the columns are set by autoruns themselves, right? So it depends on what they actually call it. Launch string. Yeah, that's it. Yeah. So the launch, so it basically knows. So autoruns is smart enough to figure out that a good persistence mechanism is these services. So it already looks for the services as part of its check, and it's telling us here's the compspec PowerShell. There's the suspicious service. So this is an example of using autoruns to do this kind of deep dive. But when you think about it, from the point of view of the user, all you have to do is just use that artifact and it just works. Cool. So that's tools. Now, the way that you define it, now you can actually use that artifact as a sub artifact as well, and you essentially encapsulate it. But let me just go back and show you again how that autoruns works. So all you have to do to create to use tools. Okay, there's a question. Quick note: if you want to select the time column from autoruns, the current version has a leading space in that column, so you'll need to do space time. Yes. So this is actually, it's not really a space. It turns out that this is a very good question. When you try and select the time, it's actually a little bit corrupted. That's a good question. I've noticed that with the autoruns, it's oops, if we look at the raw data, so it is fixed in I think it's fixed in 5.9, or no, or is it fixed in 5.9? It's fixed recently because it's not actually a space, it's actually the BOM. So a lot of Microsoft tools, they write CSV with the BOM, which is like a Unicode type thing, right? So it ends up, I think there was a version, I'm not sure if it's 5.9 or if it's head, but it's been recently fixed where we handle the BOM a little bit better by stripping it out. So in the latest version, it's actually doesn't have that problem, because just the time column is the very first thing in that file. Yeah, but yeah, it's always best to look at, again, at the raw JSON as that example. Okay, cool. So yeah, so let me just go back to the to how you define an artifact with tools. So the tools, all you have to do is create a tool section here, tools, then you give it a name, and that's all you need. You just need a name, right, for the tool. Now, you don't even need an upstream URL. If you don't want to give one, that's fine. So you can just give the tool name. And then down here in your query, you call this artifact generic utils fetch binary. That's all you do. And you give it a tool name like this, or whatever tool name you want. In this case, this artifact supports both flavors, architectures. And that's it. So basically what will happen is that this will evaluate on the client, and it will return a path on the client with the full path that has the path of the binary on the client. So it will take care of everything. It will take care of downloading it from the server, storing it, checking the hash, and then it will just return this full path column in that. And so then we could just use it as it is. So it's we can use it. It doesn't have to be an executable. You can also just use files for this. So you can use like Yara rules or anything really. It just makes sure that file ends up over there. Cool. So once we have that that artifact, the Windows sys internal auto runs, we just call it, and we don't need to worry about actually how it works. It's fully encapsulated. So if you create an artifact like this that calls another artifact, then it will take care of pushing the tool, running it, executing it, getting the results back, and then ends up calling this this new artifact on top of it. So yeah, so this is so I'm just going to show you that. We won't need to do that, but it's just fully encapsulated. That's the point of this slide. Okay, cool. So a summary for third-party binaries, this is a super useful feature which essentially turns Velociraptor into an orchestration tool. On the client side, when you evaluate this artifact, then it delivers the file to the client on demand, and it maintains the local cache of the binaries. So also the other thing is that if you upgrade the version of the binary, so like let's say another autoruns, a new version of autoruns is available. So, over here, all you have to do is, in fact, in any you just click on this artifact setup, right? And then if you just re-download the file, then that hash may change, right? I don't know, if a new version appears, let's say, of autoruns. So that hash will change. So what will happen is, if we now use it, then the endpoint will compare its local hash to this hash that the server said use this hash, and the local cache would be, maybe the old version, right? And because the hash doesn't match, then it will re-download it again and make sure that it's correct and then run it. So it's basically takes care of upgrading versions automatically as well. So it just works for upgrading. And then this is the cool thing: when you have the offline collector, it just works the same way. So you don't really need to think about it. You just write the artifact once, and then the same artifact will work in exactly the same way in both contexts, but it works differently, obviously. With the offline collector, it will also package up those binaries in the collector, and then unpack them at runtime and take, so it does different things, obviously, but from an artifact writing perspective, it's the same. Okay, cool. So any questions about tools, using tools? No, cool. All right. Let me just go on to the next topic, which is the automation of Velociraptor. And in the very first module, we talked about VQL and Velociraptor when I was introducing VQL and Velociraptor. And I mentioned that VQL is used everywhere in Velociraptor. It's used in, to collect things from client, and it's also used to evaluate things on the server. And we can see that we can evaluate things in a notebook on the server because that notebooks run on the server. So when we have a notebook, then whenever we write a query, we can that runs on the server, and so the query can be, can affect the server or change things on the server. But you can also run a server artifact as well, and so this can be used to automate the server and control a lot of these things. So essentially, anything you can do in the UI, you can do in VQL. So that means that VQL is like an automated way of running things on the server. So server artifacts are essentially a way of, like any other artifact, it's just encapsulating VQL that's supposed to run on the server, right? So we can actually develop all of our automation as a server artifact. And it's exactly the same process, right, that we've done so far. We just write our VQL in the notebook, and then when we're ready for it, we just create a server artifact. So let me just go through some examples. And this is the part of the documentation site that explains about the different functionality that's available for just on the server. So for instance, the things that you can do on the server is look at all the clients. So this plugin just produces a list of all the clients. So you can filter by clients, you can search by them, and so on. You can collect from the different clients, collect new collections. This is an example of filtering by various things from clients, right? So we select something from clients, and then we filter by last seen dates, and then check with group by version. So we check how many clients are on, belong to different versions, and so on, right? So this is a way of just getting like the progress of an upgrade when you're doing an upgrade. Okay, so just a couple of concepts before we dive into it. These are just terminologies. So in Velociraptor, a client is the instance of Velociraptor that's running on the endpoint. So it's that program, Velociraptor program, that's running on the endpoint, and we talk to the client. So internally in the Velociraptor server, we refer to each client by its client ID, which is a unique ID of that client. And there is a client index. So we can search for clients from the index, and it's a lot more efficient than just doing a row scan over all clients. So you should know that there is an index there. And clients have labels and other things. So there's lots of properties in clients. So this is just what clients are. A flow, this is more of a GER holdover. The term flow refers to a particular collection. So it's just a single collection instance, right? And each flow is essentially collecting a set of artifacts, one or more artifacts. And each artifact could have sources. So it could have different sources in the artifact. But each flow collects one set of files that are uploaded. So if we're doing a Cape target, a Cape files target, for example, it will be uploading a bunch of files. Those files are stored inside a flow, right? Now, if you collected the Cape file targets and another separate artifact, then all the files belong in the same flow, but each artifact has different result sets that come back as different JSON files. And then a hunt is essentially just a collection of flows from different clients. So it's just an aggregation of collections of flows. Okay, so let's look at the first exercise, and that is label the clients. And so we want to label all the local machines with a certain local username. So this is a very common one because we use labeling to target hunts and also to target monitoring, event monitoring. Remember that when we went here, then we can select a label to target. So in the UI, we've still got those. These are the pool clients from last time, so that's good. So we've got quite a few of them from the last module, but they're obviously not online right now because we're not running it. But you can just go and create a label from the UI, and that's fine for one or two. But it's not used when you have many different labels, right? So if we look at each of those, then we might have generic client info, and you can see that we collect the users just as part of generic client info. We collect the user listing, and we might want to say all the machines that have the user mic in there, we want to label them specifically. And this is what this exercise is about. So we're going to look for all the machines that have that user mic, and then we're going to label them, with a specific label, right? Then we can target hunts on those. So let's see how that works. So if we go over to, okay, so let me I'll just start up the, yeah, I mean, so in order to do that, let's start off with getting, let's say, user listing, right? So user listing, right? We'll run a hunt and look for users. Okay, so WinSys users just gives us the user listing. So we'll launch that, and our pool clients are not running right now, but so we're only going to have one machine that's the one that's active right now, this green one. So when I launch the hunt itself, that's the creator, launched this collection, right? And then the collection ran, and these are the results. And there is a user called Mike in there. So that's cool. So let's now find out. I'll just use the hunt to label, right? So I'm running this hunt, and by default, let me just get rid of this because it's kind of too long. Yeah. So by default, it's going to show me the first 50 rows from all the users, right? But I'm only really interested in the one row that has where name matches Mike, right? So I only care about this user Mike and only those machines that have that user. So it's going to come back and say, okay, that machine, only that machine has that user on it, right? So that's cool. That's great. Now, so there's nothing new here, right? So far, we know how to do post-processing, right? So we found all the machines that have the user mic on it. So that's great. But what we want to do now is we want to actually label those machines. So we're going to use the label function, which adds the label to the client, right? So what parameters does it take? Question mark. So the first thing it takes is client ID. Great. So where is the client ID? It's this one, right? So client ID, great, copy, paste. All right, and then what's the next parameter? The labels. Obviously, we want to label it. So, what are the labels? Let's label it Mike, right? And then we have an op, which is the operation. And it says an operation on the labels, set, check, remove. So we want to set it, yeah, set. And that will set that label. So labels are like bits, right? They just set or clear. They it's either set or it's clear. So anyway, we just run this thing, and when we evaluate that, then you'll see that it set the label, right? And it's just showing us that it set the label here. So when we go over here and look at all the users, then you can see that that label's been set, on that machine, right? So that label's set. So that's cool. And so you can see that you can use that. You launch a hunt to get all the usernames from the endpoints. So we just did that. That's cool. And then we run this VQL to search, filter that hunt, and then we label the user, right? So that's a good way of grouping by user, and you can group by any number of things, right? This is just an example, but for example, if you can develop some kind of a VQL to tell you whether a machine is a server, like an Exchange server. If it's got Exchange installed, maybe it's an Exchange server. So we're going to look through and say, all the machines that have a product ID of Exchange, we're going to label them as Exchange server. So then we can run hunts on them, or maybe exclude hunts from running on them because, maybe they're very, very sensitive and we don't want to upset them or whatever. Or if the machine has a PII, yep, then exactly. So you can if you can find a VQL that reliably tells you whether a machine is should be labeled in a particular way, it has PII or should be sensitive or whatever, then you can automatically apply the label to it with that property. And so this is actually so this is like a two-step process. You apply the label, and then you start hunting them, and then direct your hunts towards them. So that's cool. I have a slide here about labeling clients with an event query, but I think we're running low on time, so I'm just going to skip that. Other than to say that this example is in the wiki anyway, or is it in the quiz? I'm not sure. I think it's in the wiki. Velociraptor GitHub. I think there is a wiki here with lots of interesting examples as well. So we have a wiki with custom artifacts library, and I think it's here. You guys can add to it if you label clients containing username. So this one is an event artifact. So this is the answer to this one, but try and figure it out yourself as well. But this one is quite an interesting one. Okay, I'm just going to move on to the next topic real quick, the Velociraptor API. Okay, so the API is a way for us to automate the Velociraptor server, and we use the API to connect to the server. So when I say Velociraptor API, what I mean is that another program, so I'm going to write another program, let's say in Python or C# or whatever, C++, whatever other language, and then I'm going to have that program control or use data or interact in some way with the Velociraptor server, right? So from another machine or another thing. So that's what I mean by API. So APIs are usually consumed by another program, an automated thing, right? So it's not for humans, it's for machines. So why have an API? Of course, in a real deployment, Velociraptor is just one part of a much bigger deployment, right? A much bigger ecosystem. And we've already seen how Velociraptor can interact with other tools in the ecosystem. We've seen how we can forward messages, we can forward things to Elastic. We've seen that. So you can imagine, you can see how Velociraptor is part of an Elk stack now, right? We can also interact with there is one artifact here with a Slack, right? So Slack, this is a Slack interaction. this is an example of, basically whenever a client comes back online, we get a Slack message, say, hey, this client came back online, right? So this is an example of interacting with Slack. And the way it works is using this HTTP client, because a lot of external systems like Slack have a RESTful API. So if you have a RESTful API, all we have to do is use HTTP client to make HTTP connections, and then we can interact with their API. So we already have mechanisms in place that we can use to interact with other systems, right? We can control other systems already. But what I'm talking about here in this example is having Velociraptor be controlled by other systems. So having my script, my Python script or whatever, tell Velociraptor what to do. So obviously there is an issue of security here because we need to make sure that that whatever it is that's controlling Velociraptor is authorized to do it. And then obviously, because Velociraptor is extremely privileged, right? Because it has, essentially root everywhere, right? So we need to make sure that that we have secure communications to it firstly, and then authentication. So over here, this is how it works, right? So we have the client program, which is, we call it the client program, which is a Python script. Let's say Python script, doesn't have to be, but just an example. And then it connects over to the server to an API server port. So there's an API port. And the connection is a TLS with mutual certificate verification. So the server has a certificate, and then the client will check that certificate, right? And similarly, the client has a certificate as well, and the server will check that certificate of the client, right? So it's mutual certificate authentication. So we don't use a REST API because it's actually difficult to, it's much harder to actually code around. We use gRPC as the underlying technology. But when I say API, there is no need to expose a very complicated API surface. All we have to do, I mean, that's already complicated enough, is just expose the ability to run VQL. So the API is really just a conduit for running VQL. And of course, with VQL, we can do absolutely everything, right? So it is an extremely powerful mechanism, API, but it's very, in terms of the API surface, it's very, there's really only just the one method call. Okay, so by default, the API only listens on the local host. If you want to expose it, you have to change it, right? Because just because API is not something that a lot of people need. So by default, we install it in a secure way. So it only listens on localhost, and then you have to reconfigure it to just change it, the port, if you want, change the binding address. So let me just show you how an example. So before we can connect to, let's go over to user mic downloads. Oh no, so app data local temp. So this is where we install the this is the server config YAML. So when you run Velociraptor GUI, by default it uses the temp directory to put its files, and it creates its own server config YAML. So really, that's what we need now, the server config YAML. Now, in order to connect via the API, we have to create an API key. The API key, remember that this is the picture here, the client program has to have an X509 certificate, right? So we have to produce a certificate for it, first of all. And the API, so that's the API key in a sense, right? It creates this API config. So what we're going to do is we are just going to run the Velociraptor binary, downloads Velociraptor. Okay, and then we give it the config file -- config, this one, right? And I don't know why it insists on doing this. Let me just this out a bit. Yep. Okay, and if we, and it's going to be a config file, so we need for it to generate a config file. Now remember, we did before config generate -i, that generates the config. But this time, just do -h, we need to generate an API client config, right? So it's a slightly different type of configuration file that's used by API programs, by external programs. So it's a different command, right? We're configuring an API client now. And then it's telling us that it has a name, and because every API client, every program has a name. And that name is really more to do with, it's essentially a username. When the API program, like if I'm writing a program and it's going to be something like automate, whatever, Slack communications or whatever, right? So I'm going to have this program. Then when it comes into Velociraptor, it has to have some ACLs and it has to have a username to attach those ACLs to it. So I've got to give it a name. So maybe it's going to be Python. Let's call it Python or something like that, right? And that will be the name, the username that it's coming in as, right? And then we can just do -- help to get more information. So I can create a role for it, right? And so it's just like creating another role, right? But maybe I'll just call it reader, for example. And I can use a password to encrypt the certificates that I'm generating, but that's kind of that's not, it's not always useful, because a lot of the time this program has to start by itself, and so it can't have the certificates encrypted, right? But it's something to consider. And then I have to give it the name. So I'm going to call it like api.config.yaml, right? And so it's basically now created a file. Let me show you what that file looks like. All right. Now in that file, the CA certificate is embedded in the config. Remember, so it goes back to this mutual authentication. So that allows this client to verify the certificates over here, because the CAs, it knows what CAs made it. And then it has a client cert and a private key. Then there's a connection string. And usually the API program knows how to connect to the API ports that way. So you might need to change that. You might have a public IP address here or whatever. So you might need to change that. And then this is the username of the of the client, but it's just here for reference. The username is in the certificate, right? So that the certificate identifies this name, right? So it's not this is not really used. It's just here for reference. So that's cool. So now we can use that API client to connect to the server. But before we do that, let's start to use let's install the Python bindings. Okay, we have a question. Can the API connection string resolve DNS? Yeah, so it's just a string, and you can see in the Python code, it's just connecting to that. So it would be the DNS name of, if you have a public DNS of that API port that you're accessing. Yeah. So it is just a connection string. So I'm going to install Python. So I have Python here. Python installed, and Python has, so this is just an example. You can use other programming languages as well, but Python has something called pip, right? And you can use pip to install packages, Velociraptor. So what we'll need to install is PyVelociraptor, right? And PyVelociraptor is the Python binding of Velociraptor. and it's going to download it, and it's also going to download all the dependencies and things like that it's going to need for it. So I think we need also cryptography as well, because I think it doesn't download that by default. Crypto. I think we have to fix that as a Python dependency as well. So if you have an older version of Python, by the way, then you're going to need to use, yeah, see, we're going to need to do this, what it's telling us to upgrade pip, because it's trying to build, oh no, that's working. Otherwise it can't install cryptography for whatever reason. Oh no, so yeah, I think it's working. I don't know. No, yeah, so it's not working here. We have to do what it's telling us here to upgrade pip. And then it will install correctly. All right, there we go. Come on, yeah. So it's like a Python issue with. It's actually I think the problem is with the cryptography package, but they started to use some weird thing. Anyway, it's working now. So yeah, so after upgrading pip, and then you can install Velociraptor and cryptography. So Velociraptor is the Python bindings. It's not really binding actually. It's just it is just a Python client side code for connecting to the server. But you know, we don't really need to write code. It also install a Velociraptor binary. Sorry, it's not a binary. It's a script. Velociraptor. And it's just an example script, right, that allows us to connect. So it literally just connects to the API, runs the query, and then shows us the results on the screen, right? So it's just an example. You can use that to, you know, write your own Python code. So we can use that as an example. We're going to config. We're going to use that API config YAML that we did before, and we're going to run a query. Select star from info. Right? So again, the hello world of VQL. So we try to connect, and it's telling us, no, you can't connect, right? Permission denied, right? It says user Python requires permission any query to run queries. So what's happening here is that if you recall, up here, we'll just do it again. In this command line, I gave it a reader role, right? I said user Python is going to have a reader role. And when I created that, so it has a reader role, but that's not enough. In order to connect over the API, it needs to have an API role as well. So just having a reader role means that you can use the UI as a user, but you can't connect over the API. This is why it's giving us permission denied, because I don't have this API role. So at the minimum, all of your programs have to have the API role like this, right? So in this case, it's getting both roles. It's getting the reader role and the API role. So I'm going to do that. And now it will connect, right? But it's still got a permission denied because it can't do this, right? Select star from info. So what's happening here is that it has a reader role. The readers are only allowed to read stuff that's been collected, right? And what I'm asking it to do with this VQL is to tell me about, I mean, info actually tells me about the running system, right? So it's telling me about what the server is running, right? Which is privileged information, right? So it requires a machine state. It requires that permission, but we can't know about, you know, the internal state of the server without having this permission, right? So as a reader, I don't have that permission, so it's refusing it, right? So, because you can imagine that I could simply do something like this: exec VE, right? Arg V equals, cmd.exe, right? Dash C, right? If I do this, then that's obviously not allowed, right? I'm only a reader. I'm a low privileged script, so I only have low privileges here. So when I do this, it's telling me I don't have the exec VE permission, right? So I can't run external code. This is really important, being able to lock down the API keys permissions and roles, right? Because you have a script here and you can't necessarily, so if I just do select star from clients, that's okay, because I can read all about the clients, right? As a reader, I'm allowed to read about clients. So I'm just getting all the information about the clients. That's okay. I'm allowed to do that, right? But I'm not allowed to run programs on the server, because that can compromise the server, obviously. And I'm not allowed to know about internals of the server, like what the OS is or what it's running, these kind of things. So this is the permission models, right? We're trying to make sure that we don't have extra privileges here. So if I go and you can give this administrator right? And now it can do everything, right? You can even run execute commands, right? So here, see, that's running the command prompt, right? So as an administrator, you can run anything you want on the server, right? So where can we find available API roles? So the API roles that are available are, we had that slide, right? So it was on that slide, and it's also in the code. It's just here, right? So ACLs, roles. So these are all the roles that are available, right? These ones. And these are the permissions that are given for each role. So if you're an administrator, you get everything, right? If you're a reader, you get this permission. And if the API gets these permissions, analysts get these permissions, these kind of things. So there is a mapping here. You can actually see what roles you've got as a user as well. So for instance, here, we can run ACL show Python. Again, Python is the username, really, right? And it's telling me that Python, the user, Python, is being given these roles. But those roles are actually represent permissions, right? So they're just, essentially a role is just a collection of permissions, right? So if we use the effective flag, it explodes the roles into permissions. So it tells us all the permissions. So, file system read, I'm allowed, because I'm an admin, right? I can read file system. And basically, these are all the permissions because I'm an admin. But if we went back to the reader API role, right? And then I'll have very few permissions, right? Because I have any query because I'm an API role, and then I can just read the results. But I can't do things like notebook editing, server admin, like all of these things can't do, right? It's a low privilege. A reader role is a low privilege role. Cool. But then similarly, you can't schedule collections as well, right? So you don't have the collect clients permissions, so you can't do that. So because you can't do that, this script cannot schedule new collections. It can only read existing results from clients. So that's kind of how the ACLs work. And the idea is to try and lock them down as much as possible. Okay, cool. So I just have this one quick exercise here. We'll just do this this is what most people want to do with the API. is they want to go ahead and collect a, oh, we have a quick question. How can we invalidate the API config YAML? Oh, this is an excellent question. So you have an API config that you've issued. So you've issued a certificate. How can you invalidate it? Well, super easy. You just grant. So you just remove the permissions, right? So you grant the principal Python, right? And then the policy can just be empty. So that policy, where are we? Yeah, that's it. So granted no permissions, you see? So if I just granted no permissions, so when you do grant, it overrides the previous permissions. And at that point now, you can't connect, you can't do anything, right, with this key anymore, right? Because everything is denied. So it's like you're locking out the account, right? So this is, yeah, so this goes back to the question, how can we invalidate the API config if it's been compromised? You just revoke it, revoke the user. Okay, cool. Let's go back to this. So yeah, so this is something that I wanted to cover because people always, the main reason that people want to access the API so that they can use an external program to just reach out to another client and collect something from it. Now, so that means it's actually a little bit more complicated than just, reaching out, because what you have to do in that case is you have to schedule a collection. But then scheduling the collection is easy, but scheduling the collection happens instantly. You just schedule it, right? But the client may be offline. Usually if it's online, it will actually take maybe a few seconds to run the collection. So you have to actually wait for the collection to be scheduled. So let me show you this how we would do this. So let's go back to our API. Let me just grant -- role administrator, bring that guy back. So we just grant the role. And what we're going to do now is we're going to schedule the collection, right? So I'm just for the sake of simplicity, I'm just going to copy that client ID because it's going to be different each time. Schedule it on this client, right? So so here I am. This is the client, and this is going to be the client ID. I'm going to try and schedule a collection on this client ID, right? So I'm just going to paste that in, and just for the sake of arguments, I'm going to schedule a generic client info, right? So if I just run this, then it's oops. Oh, sorry, it's env. I think we made it. Let's stop the yeah, it's env not args. Okay, so so you see what it does is it actually calls the collect clients function, and then you will see a new collection added, right? Generic client info. It just adds the collection. The creator is Python. That's the username that created this collection, right? But you see that it just scheduled it, but it never really. We have to wait for it to come back, right? With the results. So what we really want to do is we want to block this API call until the results come back, right? So so the way we do this is the scheduling is easy, right? But now we have to block it. So the way we do this is we have to watch for the event that say that flow is completed, right? And so we run this query that watches for this event. So it's an event query, and it just watches this queue, system flow completion. System flow completion is an internal queue that will generate a row whenever a flow is completed. right? And it will have in that row, it will have the ID and all this sort of stuff. So what this does, and notice that we have a limit 1. So we're looking for one event. There's going to be one event that says this flow is completed. And just like any of the other queries, it will block, this query will block until it gets that event. So it depends on this, if this client is connected or not. So let's run that. And you see that it will just compare that flow ID to the flow ID that it receives, right? So when I run this, it will just wait until that client returns from that collection, right? So it completed, and you can see that it returns because we selected from that watch monitoring. Then it got the information of total collected rows. Here's the results, but it's just like the metadata of the results, right? So what we want to do now, so we want to wait for that. And then, so again, with VQL, you don't really need to put the line breaks, right? And you don't need semicolons. You just keep writing, right? So, so we can just put them all on the one line. It's not super readable, but. So what we want to do is we want to actually get the data, the results that were collected, right? So in that case, what we're going to do is, so after the thing is completed, then we call the source plugin, which just reads the results from the server. We give the client ID, the flow ID, and the artifact that we want to read, right? So we just do that. And so you'll see that what happens, our client ID, I have to copy the client ID in again. The client ID was this. Okay, so it will so you'll see that in the first, this is the flow results, and then this is the results that were collected, right? So that's coming from the client. So so I just wanted to show you this example of putting all of these together, scheduling from the client, waiting for the results, and then reading the results. And if you don't care about the metadata, like how many rows were returned, things like that, then you can just do this, let underscore. So remember that we're using the arrow operator, which is materialized. So it's basically going to expand that query at that point, just wait for it, and then it will discard, it will assign, the result to underscore, which is essentially discarding the result, but it's just waiting, and then we're getting the results back. So every time we run this, it will schedule, it ends up scheduling, waiting for the client. See, these are all just coming in, scheduling, waiting for the client, getting the results back, and then dumping them out into the API. So I just wanted to show you this because that's a very common pattern. Okay, so we are kind of out of time. So we don't really have time for doing these event queries and server monitoring thing, but we've seen the watch monitoring example where we are looking for an event that happens, right? And this is what we did in the previous example. We're watching for this system flow completion. You can actually see it here. So in this, so we can see system flow completion. This is the artifact. So it's an internal artifact, and it's basically receiving events from whenever we complete any flow on that host, on that machine, right? So we can watch for that queue. We're watching for it, and this is how we can essentially be informed that a flow is completed, right? And okay, cool. Yeah, so we're going to skip this server-side VQL event artifact. As a question, can you mention anything about the current roadmap for Velociraptor? Yeah, so Velociraptor, the current roadmap is still, forging ahead, the same as always, right? We want to make this the best open source DFIR tool out there. So we are really grateful for our community, and we want to have everyone participate and belong with this project, right? So it's a community project. So we're going to develop more of the artifacts, more of the detections, build out the scale to go up to much bigger scale. Yeah, it's exciting. All of these this is the roadmap. So it's an open source project as well. So what we really love from our community is for people to help us drive our roadmap, right? So file issues on the GitHub, tell us what you would really love Velociraptor to do, and in your environment and your use cases. Because realistically, I think that like my role as a developer in Velociraptor is to build a platform, and then I'm just going to really love to see what you guys, the community as a whole, make of it, right? This has all been so far community driven. People have been telling me like what they would like the tool to do and the type of features that they would like to have. Yeah, this is so it's a community thing, right? Like you guys are driving it just as much as I am. So yeah, that's the roadmap. I can't give you any more detail. It's up to you guys to let me know. How many more people? Yeah, so the team is growing, right? So we're gonna have a few more people now. So that would be pretty cool. Yeah, so I'm just going to skip that last one and just jump to the conclusions. Yeah, you guys can read the conclusions, but yeah, okay, cool. So yeah, there are lots of more examples in the quiz, and if you guys have any more questions, let me know. There's a few questions here, is there? Can't tell, how does the artifact for updating Velociraptor version on the endpoint work? Oh yeah, okay, that's an excellent question. So you can do remote updates, and it's really simple because this is the remote update artifact, and you can see that it's super simple. It has a tool. I'll just show you the thing. So again, we talked about tools today. It just has the tool name, so it doesn't have a URL, because we're expecting that you guys build your own MSI with your embedded config, right? So you basically declare that as a tool, and then all it does is it runs the fetch binary to bring the tool, the tool over. We have to copy it out of we have to copy it away from the place where it normally caches the tools, because we're about to uninstall it. So we have to copy it away from there. But that's really the only trick. So once we copy it away, we execute MSI exec. That's it, right? So it's actually pretty straightforward. In your experience, do customers often have problems with running the server in the cloud? No, we usually run it in the cloud, right? That's the recommended place to run it. So yeah, in the cloud is usually the easiest way. Is there a centralized place to search and share community custom artifacts? So that's an excellent question. So if the artifact would be more useful for everybody, then we can put it into then of course include it as a part of the built-in set. But otherwise, there is the wiki here, and there's a whole bunch of different artifacts here. Usually I just do a GitHub gist or gist, whatever you think, and then just paste it there. And a lot of these ones actually ended up in the built-in artifacts, from the wiki, right? I usually kind of put in like an artifact that's was useful in a job, or just put it in the wiki or whatever. Cool. All right. Great. So let me just stop the recording. Do you guys